Good morning. We are going to review arithmetic and geometric sequences. So my goals for this little lesson are to go over what it means to be an arithmetic or geometric sequence. We're going to identify the sequences, identify common difference or ratio. We're going to calculate terms. We're going to write an explicit formula, write a recursive formula, and then calculate an nth term. So we'll start off with these first examples, which are determine each of the following sequences if they're arithmetic, geometric, or neither. And if they are arithmetic or geometric, we are going to identify the common difference d, or the common ratio r, and then calculate the next three terms. So for this first one, we can see I'm starting off with some negative numbers, and they're increasing a little bit. So I'm going to check first if it is arithmetic, which means I'm going to be taking the second number minus the first number. So I'm going to take negative 8.5 minus 11, or minus negative 11 rather, and I get 2.5, and then I'm going to take my third minus my second. So I'm going to take negative 6 minus negative 8.5, and if this comes out the same, that means that's my common difference, so it is, which means that this sequence is increasing by 2.5 every time. So if you keep moving to the right between your terms, what you are doing is adding 2.5 every time. So that means that your common difference is 2.5. And if I want to calculate my next three terms, all that I have to do is add another 2.5 every time. So I'm going to take negative 3.5 and I'm going to add 2.5, which means my next term is going to be negative 1. And I'm going to add another 2.5 again to that, and I get 1.5, and then again add another 2.5 one more time, and your last term is 4. Okay, so that was an arithmetic sequence. Common difference was 2.5, and then here are my next three terms. For this next one, let's try doing the same thing with taking the second number minus the first. It looks like these are increasing as well. So if I do 1 minus negative 4, I get 5. If I do 5 minus 1, I get 4. 8 minus 5 is 3, and 10 minus 8 is 2. So there is a pattern here. It is not arithmetic, even though it looks like there's some kind of pattern with these numbers right now are decreasing by 1, but this is not a constant common difference. So you would need all these things to be 5 or all of them to be 4 in order for them to be arithmetic. So even though there is a pattern, this is going to be a neither. But I can still, I guess we could find the next term. If it looks like this is decreasing, or from 8 to 10 was increasing, I should say, by 2, that means from 10 to 11 it would be our increase of 1, and then that would be the last term of this. We couldn't go any further than that. And then the last ones, I picked, this one's going to be a geometric one, but we can try first to see if it is arithmetic. If you take 12 minus 4, you're going to get 8, and if you take 36 minus 12, you're going to get 24. So that right there tells you that it is not arithmetic. It is not increasing by a constant amount. So what we're going to do is check for geometric, which is very similar. I'm going to take the second number divided by the first number, and the third number divided by the second number. And the reason we use division from right to left is because in order to get our future terms, you always multiply by the common ratio. So if we're working backwards, working left, we need to divide. So 12 divided by 4 is 3. 36 divided by 12 is 3. And in your calculator, if you take 108 divided by 36, you will also get 3. So this tells me that this is geometric. My common ratio here, r, is 3. In order to get my next three terms, I'm going to take 108 and I'm going to multiply it by 3. And I get 324, and then I'm going to multiply that by 3 as well, and I'm going to get 972, and then multiply it by 3 one more time to get the third missing term here, so 2,916. So the geometric sequences grow a lot faster because you are multiplying by a number, and they're exponential. And then lastly, I put a fraction problem on here just to get some practice putting fractions in the calculator. You can do these by hand as well. Yeah, I mean, why don't we just, whatever, I'll do it in the calculator. This looks like what's happening is that I'm doubling the numerator every time. So if we do take a look at this, how you would put this in the calculator, if I'm going to check to make sure it is geometric, I could take 2/3 divided by the term before it, which is 1/3. and it looks like it doubled, and then I will take 4/3, which is my third term, and also divided by the term before that, which is 2/3. So I'm taking the third term divided by the second term, and that number also comes out to 2. So I did give another geometric example here. Again, this because I'm taking my second number divided by the first and the third divided by the second. It means if you're moving right to left, we divided. So moving left to right, it's multiplication, and you are multiplying by a common ratio of 2/1, or just 2. So now if I want to find my next three terms, basically just look at the pattern here. Your denominator is staying the same, and your your numerator is multiplying by 2. And the reason for that is your common ratio is technically 2/1. And if I take 8/3 and I multiply it by 2/1, notice your your denominator stays the same. 3 times 1 is 3, and 8 times 2 is 16. So what's happening is the numerator itself really is multiplying by 2 every time. So if I want to get my next terms, just keep multiplying by 2. I would get 32/3, and then the last one would be 64/3. And then for these next ones, we're going to be writing the explicit formula for the sequences, and then we're going to calculate the 32nd term. So we're going to use our formula then. This first one is a geometric one. I didn't write that on here, but this is geometric. And then this one I made is arithmetic. So we'll do the geometric one first. I'll leave it up to you guys if you can answer this in your own head first of how would I find a common ratio if it's geometric. It's something you should be able to do. You should take the second divided by the first. Again, just to refresh your memory, if you take 1.5 divided by 0.5, you'll get 3. And same thing here, if you take 4.5 divided by 1.5, you'll also get 3. And what that tells us is that our common ratio is 3. The other piece of information that we need is my first term, a1, which is a half. So now I can just use my little friendly formula. Again, the formula for a geometric sequence is an, where n is any term number. You take your first term times your common ratio to the n-1 power. So for us to write an explicit formula, which is part of the directions, a sub n equals, we're going to take a1, which is the 0.5, the first number in the sequence, times the common ratio, which is 3, to the n-1 power. And make sure when you are evaluating this for any term number, you would always do your exponent first because of order of operations. You cannot simplify this by multiplying these two together and taking it to the n-1 power. That is a huge no-no. So if I want to find the 32nd term, we're just going to substitute 32 in for n. And I will write it up here as the power of 32 minus 1. So that's going to be 0.5 times 3 to the 31st power. And I'm going to just throw this in the calculator because it's going to be a ridiculously large number. So I'm going to take 3 to the 31st power, and holy cow, that is huge. And I'm going to times it by 0.5, and I get 3.088 times 10 to the 14th power. And that was using a little scientific notation on the calculator. My calculator said 3.088 blah 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 E14. The E is a fancy way of putting in scientific notation and saying times 10 to the power of, and then in this case it's 14. So what that means for us then is we could take this decimal and slide it 14 spots to the right, and that would be my 32nd term. So again, with this being exponential, because it's geometric, it's going to grow at a very, very, very insanely fast rate. And then the next one. This one is arithmetic. I'm going to do it the same way, same colors. I'm going to take, first of all, 7 minus 10, which is -3, and 4 minus 7 is -3, 1 minus 4 is -3. So it's arithmetic. Again, I already said that. So the common difference in this case is -3, which means if we're moving left to right, you would be adding -3. So that's why the numbers are decreasing, is because your common difference is a negative. And just like in the last problem with common ratio, we have common difference. We needed the first term there. We also need the first term here, which is 10. And now I can build my formula. For an arithmetic sequence, it's very similar. A sub n is any term number. I'm going to take a1. Now over here it was times r because we know that we know that we multiply by the common ratio. In this case, it's arithmetic. We know that we add the common difference, and then before it's exponential for geometric, which means the n-1 was in the exponent spot. Arithmetic is linear, which means we're not going to be putting the n-1 in the exponent spot, and we're just going to substitute our values in. So you're going to put 10 here for our first term, plus -3, and then n-1. So now if I want to evaluate this for the 32nd term, a sub 32 equals, and I'm going to do 10 plus -3, and then 32 minus 1 is 31. So that is 10 plus, and then you want to do this multiplication to the side first before you cannot do the addition, so this comes out to -93. And then if you take 10 plus -93, you'll get -83. And just a way to kind of quick check to make sure you did your order of operations right and everything here, since the numbers are decreasing, it looks like we would end up with a negative number for the 32nd term, just because right after this 1, your next term would be a negative number, and everything after that would also be negative. So that means that your 32nd term is -83. And last thing too with this, I just want to make a quick note. As far as notation goes, with this one being geometric, we would want to change these little guys to G's. My apologies. Instead of the A for arithmetic, we'll use G for geometric. And then over here, I can keep these ones the same. And then the last ones. So writing recursive formulas again. The main difference between recursive and explicit is for an explicit formula, I can just say calculate the 50th term, and you don't need any other terms before that besides the first one. For a recursive formula, if I say find the 50th term, we want to know the 49th term. If I say find the 4th term, we want to know the 3rd term. And you can build off of that using the common difference or ratio. So I'm going to write the two forms out before we even really get into this. And that is for an arithmetic, it is an for any term number. You take the term before it, which is n-1, and you just add the common difference. For geometric, we would take g of n, where n is any number of term, and you're taking the term before it, but you're not adding the common difference. You'd be multiplying by the common ratio. So these are going to be the two forms that we will end up using, depending on which one of these is arithmetic and which one is geometric. So first of all, with this, this one is our arithmetic sequence. I know this because I made the problem and I should have indicated it, and this one I made as a geometric. So for this first one, just to because it is supposed to be arithmetic, I'm going to find the common difference by taking the second number minus the first number. So if I take -3 minus -5, I'm going to end up with 2, which is my common difference. And then what I can do is write a recursive formula for this. Real easy, real easy. Take an equals a sub n-1, and all you're going to do is fill in the common difference. So this tells us my recursive formula. If I wanted to find, for example, my 25th term, I would take my 24th term and I would just add 2. So in this case, I want to use it to calculate my missing term. My missing term is my 3rd term. So in order to find a3, I need to take the term before it, which is a2, and I just need to add 2. So a3 equals, a2 is my 2nd term, which is -3, and -3 plus 2 is -1. So that means that my missing term here is -1. And that would be it for that. And then the last one is geometric. So what we'd want to do is find the common ratio first. Take the second number divided by the first number. 4 divided by 8 is 0.5, or you could write it as 1/2. And 2 divided by 4 is also 1/2. So that tells us our common ratio is 1/2. The same thing as 0.5. That should be an equal sign. Okay, so writing the formula. We're going to do Gn, G sub n, because it's geometric, and you would take the term before it and just multiply by your common ratio, which is 1/2, or you could write 0.5, but this is your recursive formula where my cursor is. So now I'm just going to switch the color just like the one before it, and we are going to find my missing term, which is my fourth term. So in order to find g sub 4, I need to take g sub 3 and just multiply by my common ratio, which is 1/2. So g4 equals your third term, which is 2, times 1/2, which means that my fourth term is 1. So again, that was just a quick recap of recursive formulas and how you can use the recursive formulas to find a missing term. Hopefully this answers all questions.